I had a request to do number 19, and we're looking at the population of owls and mice. And if you kind of think about it, you'd expect a population when it's doing well to start increasing. So if the owls are eating lots of mice, they're going to reproduce, they're going to survive, their population will grow. Maybe they eat all the mice, and then their population starts to kind of decline, and maybe it hits a bottom level, and then the mouse population explodes, and then the owl population starts growing again because they have food again. And you end up with this kind of cycle that can be modeled using a trigonometric function. Maybe not perfectly, but kind of a general up and down kind of pattern. All right, so they give you these equations here. The first part asks you to find the maximum number of owls, and also after how many years does it happen. This problem can be done a bunch of different ways. Here's the owl equation. Remember, just from a graphing standpoint, you really should be able to do this problem by hand. Notice that the owl population midline is going to be at 150, okay? So if you're graphing this, it starts out at 150. Notice that the amplitude is 30. So the owl population, and by the way, also notice there's no phase shift here. It's not shifted to the left or right. You don't have anything being added to the t there. So it's going to start out in the middle at 150, and the population is going to go up, and it's going to come back around. It's going to do this sort of thing. It's all going to be cycling around 150. Well, since the amplitude's 30, it can go 30 above 150. It can max out at a height of 180, okay? And it can drop 30 below 150, and my graph is horribly off scale here, but 30 below would take you down to 120, and I'm guessing my x-axis would not be that close. But anyway, point is, it's going to go as high as 180, it's going to go as low as 120. Remember, the distance between the minimum value and the maximum value for your function will always be twice whatever the amplitude is, okay? Now, ask after how many years does that happen, and there are various ways you can do this. You could go into your graphing calculator here. Sorry, they sprayed some stuff on my calculator, but you could enter this function here. Make sure you're in radian mode for this, since we've got this in terms of pi. Make sure your pi over 10 has its own set of parentheses. Make sure that x is inside the parentheses for the sine function. If you go to your window, okay, I know some things here, but I had my x go from 0 to 20. I'm going to have my y go from negative 10. We shouldn't get negative values, right? We know it doesn't go any higher than 180, but I want it to go to 200 here just to show you something. So anyway, the kind of lazy route here would be to go into your calculator. Gosh, that calculator's dirty. They sprayed that cleaning stuff here. Anyway, I think we've seen this once or twice. You can trace on your calculator, and you do have to be careful tracing because you very often are not going to be able to get exact values. And so anyway, if you look at the coordinates of the point there, as it gets up close to the maximum value, you'll notice you're around 5, and you know it's supposed to be 180. It kind of looks like maybe it's about 180 is when it hits its max. And that's not an exact answer. Remember, your calculator has this, that angle's good. Your calculator has this function. You can hit second and then the calc button, and you can see a maximum value for your function. Remember, if you pick a point a little bit to the left of the maximum part of your curve and click on it, and you scroll a little bit to the right of the maximum point on your curve and hit enter, and then hit enter on the guess, it'll actually give you that location of that maximum point. We can see there it's about 180, okay, and it's actually exactly 180. Your calculator is doing the best estimate that it can. So that's kind of the lazy route to do it, is just going and tracing on your calculator. Let's go back here. So there's actually part C tells us something that should really allow us to calculate this by hand. Part C says, after how many years does the size of the owl population cycle back to its original size? Well, that's the period, okay? Remember, the period is always going to be determined by this multiplier out in front of the variable here. And we don't have a phase shift, and it's not going to affect anything. Remember that the period is always going to be equal to either 360 divided by that b multiplier, or because we're dealing in radians, 2 pi divided by that b multiplier. Well, b in this case is pi over 10, so we've got 2 pi divided by pi over 10. Remember, when you divide by a fraction, that's the same thing as multiplying by the reciprocal. So I'm going to multiply by 10 over pi, and when stuff cancels, we end up finding out that the period's 20. Okay, so this full cycle repeats every 20 years. That means, and that's why my original graph, I graphed from 0 over to 20. That's the period. Okay, this should be symmetrical. So for example, this middle point here should be 10 years, okay? The high point, there's no phase shift here or anything like that. It's starting out over here. So it should be halfway in between. It should be at 5. And if you remember when we traced on the calculator, the maximum happened at 5, and we also saw that as well. So anyway, part B, we already found the minimum number of mouths. That's 120. The maximum number of mice, if you look at the mice equation, kind of interesting actually. There are a lot more mice because they're little and they get eaten quickly. So we're starting out with 600 mice. The amplitude of the sine function is just 1. So you're going 1 above 600 and you're going 1 below 600, which actually kind of suggests that the mouse population is not really changing very much here in this particular case. So it looks like the maximum mouse population is 601 and 599 is the minimum. So I don't know if they're just cranking out babies so quickly that they almost always have the same number or what's going on there, but that's what the equation says. By the way, be careful. On this lower part here, or I'm sorry, on the sine part, the equation is sine of pi over 10t plus pi over 20. You need to be real careful there. If you think the phase shift is pi over 20, it's not. Remember, our form for this is sine of b times x minus the horizontal multiplier there. You've got to have that factored out of the phase shift. So notice there's a pi over 10 in front of the t. You've got a factor of pi over 10 out of both of these. That is your b value. When you divide a pi out of 10, pi over 10 out of that, you get a t. If you divide this by pi and that by 10, you're going to end up getting 1/2, I think. And so your phase shift is actually a half to the left. I guess t is a year, so it's a half year shifted off the owl pattern, apparently. So anyway, wasn't asked about in this question, but just be careful. Make sure you're actually following the form, and that one wasn't written in that form had they asked you about the phase shift there.